Hi, Wendy.
Welcome, Lauren. Thank you for coming online
Yeah,
and
no
speaking.
problem.
I think a lot of people are quite excited. We've been
Great.
just sharing some links on 3D scanning, some of the kind of fun stuff. You could probably, I'm going to put you as the main screen,
Okay.
and so that everyone could see who you are. So I think
Can I do a screen share from here, or should I send links to everybody?
Yeah, I think you actually could do, you could share whatever you want. I
Okay.
have enabled it so that everyone could share their videos, share their screens, and everything else. If that's not available, let me know.
Cool.
I will figure out how to do that. But
Okay.
you should have the capability without
Great.
any
All right.
problems. Everyone else muted themselves so that they
Okay.
don't
Well, hi,
distract.
everybody. um, should I introduce myself, I guess? Or?
Yeah, definitely. Go
Okay.
ahead.
Hi, everybody. My name is Lauren Slowik. I wear a bunch of hats. Speaking to you right now from the Shapeways offices in Manhattan. If you guys don't know about Shapeways, I can give you a quick rundown, but we are a 3D printing service and community. We started as an incubator project as part of Philips Royal in the Netherlands. And then after a year of that as a startup, we were spun out, and we currently have just over 140 employees across many time zones. We have two factories, one in Eindhoven in the Netherlands and another one here in New York City, out in Queens. I will be trudging out there in the 10-degree weather shortly after I leave you guys. So if you have questions, I'll stay around as long as you want because I don't want to go outside. But we fulfill millions of orders a day, and we essentially, the baseline of our business proposition is that we allow anyone to have direct access to the best manufacturing capabilities in digital manufacturing on a global scale. Can everyone hear me okay? Yeah? All right. I just saw a volume thing changing. So yeah, and in addition to working at Shapeways, I also am a design and technology professor here at Parsons. The program is a combination of software development, visual design, video design, interaction design. So it's sort of whatever you make it. And I teach there as well as I am also a graduate of the program. So I was going to show you a bit of my own research today and then just some other cool stuff that I've come across. Hi. Pretty sure I have this room. Pretty sure. So just going to keep going until you guys figure it out. Sorry. Yeah, let me switch over to my screen share here. So, okay. That's not the one I want. That's my personal website. I wanted to show you my research, 3DIY. So this was my investigation into digital manufacturing and sort of how it's going to be applied to anyone. So what it looks like in a world where anyone can use digital manufacturing, where anyone can make quite literally anything they think of. It started as an exploration of the idea at the time. MakerBot had just been acquired by Stratasys. The sort of the gauntlet was laid down in the 3D printing desktop world for who's going to become a household name, and I was just fixated on the concept of whether or not these household tools really would be in a household. And I can send you the link, is just 3diy.cc. The idea behind the .cc address was a commitment to open source, so all of the designs I created for this project were posted on MakerBot's Thingiverse and available to download, but really I wanted to investigate what it was going to look like for people beginning to design with very little design training. Like, what would their initial problems be? I focused on hacking your own furniture, and specifically 3DIY turned into a series of literal IKEA hacks. So this is 3 different pieces of IKEA furniture, and the pieces that I designed to change their functionality are attached to those objects. So for example, Marissa Mayer and those ads. Sorry, guys. This is the Marius hack. It's a sort of a quick little clippy piece that you can attach to the famous IKEA Marius stool to add sort of a little shelf. In New York, there's not a lot of space, so anywhere you can add shelving is sort of exciting. This was a featured thing on Thingiverse at the time, and the functionality isn't super interesting. You're very limited with the materials that desktop printers can use. This particular material is ABS, which is a type of brittle plastic that's similar to Legos. If you guys are familiar with any desktop printer, you've probably seen that, or PLA. The difference between something like these materials and something that Shapeways uses is the layers are often better fused and can account for things like torque and weight bearance. So the ability to access good printers is definitely a next step for anyone who wants to design something that's going to have more than just a sort of a desktop functionality. But the most interesting piece of, these ads are terrible. The thing that's new.
Just so you know, I've actually featured some of your links on the right-hand side on the showcase. I don't know if everyone could actually see that, but there's a showcase button, and all those links are actually showcased there. So in case you wanted to, you could also press on the showcase button, and then you could just put them in there.
Okay. I'm sorry, I haven't used this before. Let's see.
I'm just discovering all these wonderful buttons myself. So
okay.
Anyway.
Showcase. There we go.
So yeah, I put a few links on the 3D scan.
Oh, fantastic. Okay.
And your site also. So feel free to post anything to share with the group there.
Oh, okay, I will.
Yeah, it's a button called, it looks like 3 tags, yellow tags, and it's called Showcase.
Got it. Yeah, I see it now. So rather than screen sharing, or in addition to screen sharing?
In addition, so that we could probably archive this.
Okay,
also.
great. Yeah, okay, I will do that. Let's see. Okay, so back to this quick image. Really, I don't want to focus too much on my research because it hasn't gone very much further than the state you see it now, which was 2 years ago. But I was also investigating, how people can use this, the really powerful capabilities of universal processors to apply very complex engineering capabilities to simple objects. So what this is not really anything all that useful in the larger sense, but the way it was made is more interesting. The ribbon-like pattern was an investigation into optimizing based on something called topology. So in biological growth patterns, topology optimization happens automatically. I'm looking at the blog post right now called Topology Optimization, or Ribbon Candy Doodles. So basically, it's essentially like three-dimensional corrugation based on load-bearing requirements, and which is like the least sexy, most complicated thing you could present to someone who's trying to just make a can opener on their desktop printer. But the interesting thing about it is that it's the one way of designing that leverages the advantages of 3D printing, and that is making truly unique shapes, truly unique geometries that are also incredibly functional. In this case, this was a first prototype that I sort of fudged the fitting just to see how flexible it would be, and I realized that I needed to be a little bit more precise. But I was really interested in how very little material I actually used and how actually quite strong this piece was, even though it was rather flexible. So I think in my exploration of all this research, the shortcoming that a lot of people maybe don't realize is that the tools we use for 3D printing directly are really all these what we call skeuomorphic tools that were made for other requirements. So whether it was speccing out an architectural model or prototyping the look and feel of a finished hand drill, but the software was never actually created to design and then also to produce. So there's often a disconnect there. So you'll see, I think the biggest space to watch for new stuff is going to be in software. Wendy, you mentioned you talked about scanning. What have you guys talked about with 3D scanning so far?
So the discussion for 3D scanning is actually for Thursday. Some of the students have are going to be presenting their one or two or three different types of research, and beyond that, I think I got really into understanding your process of the Connect and scanning through you scanning me at the Museum of Art and Design, if I remember. And I think what we are trying to explore with the students with the scanning are kind of various scales, body scale to architecture scale, on what they could actually rig themselves. A few of the students are quite savvy with using their Connects. Another option is for the students to kind of play with ready-made models that they could actually buy. For instance, there's a version that Felipe, I think, researched on, and he found one that was very interesting. Felipe, if you want to talk a little bit more, you could share with Lauren what you've also found. And I think, Ryan, you also had an interesting example. Would you guys like to kind of speak up? Maybe Felipe, you first?
Sure. Yeah, we were looking at prosthetics, and we were looking at kind of a therapeutic sleeve with maybe using a rubber or silicone material. What else were we looking at? Latex, as far as materials go, and yeah, so we wanted to hook it up to Arduino, and maybe I keep hearing my own voice, so it's kind of hard.
You can mute.
What's that?
You can mute your own speaker, like on the computer, maybe. No.
Yeah, it's like hooked up to the projector, I guess. Everyone's computer? Okay. Well, anyways, we were using, we were thinking of using like Ableton Live to hook up MIDI controllers to these sensors, these triggers, so that we can accomplish like just this therapeutic sleeve that would kind of use music therapy, and then trying to create, trying to make the sound physical, so that they can feel the pulsating in their wrists, on their sleeves. So there's a couple examples of that online that we can show you. I think we have a short presentation about it somewhere. Yeah.
Cool. Very cool. Yeah, there's a lot of examples of prostheses work, and I'm sure in exploring scanning, you guys have realized that scanning is a really incredible way to translate the analog world into digital, and then sort of take that as a kind of a digital mold, which is really what you're doing, which is really exciting. My work with scanning started when the Connect came out, and specifically the developer library. Before I got interested in 3D printing, I was writing a software for the Connect to do clothing sizing online, so that one of the biggest expenses for online retailers is returns, because people order multiple sizes. So the concept was you share your measurements with the shopper's personal data, and then everyone always gets a closer or more perfect fit. Unfortunately, as you guys will probably also find out, a lot of these technologies are still very inaccurate, to the point of determining really nice tolerances that make for a comfortable fit. So as long as you guys are prototyping, I think it's an excellent collection of technologies to use.
I think Ryan also had a similar kind of approach where you were actually rigging into a Connect system. Ryan, would you like to elaborate a little bit on what you're actually exploring?
Sure. So I guess towards the beginning of this class, yeah, we're just going to see what types of I mean, using the Connect also in the developer library, it's like what programs have been made that are like, I've looked around. There's like ways to just, I mean, you just like move it around and it scans and creates the environment for you. So just, I guess originally we're probably going to just print objects that we scan. Maybe further on, look into connects just like motion sensing. I want to like either processing or the Firefly plugin for Grasshopper in Rhinoceros 5, and see if somehow a user can use movement as an input to create different shapes, which could then be turned into surfaces and 3D printed. So I don't know. Oops, I can't hear anything.
Oh, it's okay. I just said cool. It sounds cool. Yeah, the Connect is nice for that. Yeah, I think body motion is definitely its forte, especially with the skeleton recognition that they have built in. I haven't used the Firefly plugin, but if it's you can also do some nice tie-ins with any C++ library. And what's nice about that is that you're rather than processing, you're accessing the processor directly, so you get a little bit better feedback because there is a lot of data. So that's the one thing to remember whenever you're writing anything with the scanner stuff, is just that it's taking, at least 12 to 24 frames a second. So it's like thousands of images per minute, and so yeah, just look into optimizing data from scans because it can really slow down your program. I don't know, it's sort of off topic, but that sounds really cool.
I think that was a good aside. Should we go back to your research and then we'll have a Q&A a little bit afterwards also? Sure.
Yeah. So I'm going to post in a link to a Pinterest pinboard that I have been keeping since I started my research 3 years ago. So you just treat it as a sort of an image bookmarking board, but it's been really helpful to trace all of the influences of looking at this field of really what it is democratized manufacturing. So here, showcase. How do I put things in Showcase? Wendy?
What you could do, if worst comes worst, just put it in the group chat, and then I'll relink it onto there.
Okay.
Maybe it's on my end.
Yeah, I think you have to post it, unfortunately.
All right, cool. Yeah, just put it on the group chat, and I'll put it on the Showcase.
All right, 1 second. Sorry, guys. Taking a little. Now it's in a group chat. And then screen share.
Great, I got the link. I'll just
great. Okay, so this is not my research. This is projects that I think speak to the advantages of democratized manufacturing or access to industrial manufacturing capabilities. So things like CNC controlled machining or routing, carving, 3D printing, digital knitting, and digital weaving. So all of these are, and digital fabric printing, which is sort of on the border between 2 and 3D production. But there are just a couple projects I want to point out. So a lot of the spaces that 3D printing functions well in is this sort of invisible space of connecting things or making round pegs, square pegs fit into round holes. So you can take an example of like this project. Just want to make sure you guys can see this. Okay, yeah. So take an example like this project where you can use standardized gauge wood or metal, and essentially you could upload these files and publish the plans, and as long as someone could get their hands on the standardized 2x2 plywood and posts, anyone will be able to manufacture this object with the digital files and the measurement description. So this is something that's really interesting because it's distributed manufacturing, but it's distributed even amongst the facilities where the different pieces are actually pulled together. And the manufacturer, and I'm doing air quotes even though I'm not on camera, but the manufacturer is actually also the customer. So sort of an interesting space. And there's a lot of examples of flat pack furniture and things like that that take advantage of the idea that that people can actually assemble things. And then on the other end of the spectrum, so I'm very interested in how untrained or people who are new to manufacturing approach this technology, but there's also on the other end of it some really incredible research going into structural use in actual buildings. So this is a hub from a design group in the Netherlands called ARUP, and they have prototyped a method of 3D printing structural steel. And I think this is really thrilling because you can start to make truly unusual form factors in both furniture and architecture for very little money, and you don't have to do a minimum order. So for example, to make a mold for something like this in a traditional manufacturing setting would be cost prohibitive to the point of it not being possible. So it would have to either be completely handmade, meaning machined and welded, or not made at all. And they've been able to work out an in-between where they can print, I think they needed 1,100 different hubs for this tensegrity structure that these were used for, and each one of them was slightly different, and it would have cost them, I think, a good 3 to 4 times the amount to manually manufacture them. So it's still in the prototyping phase, but it's a really interesting project to think about how 3D printing acts as a sort of a way to fill the void and connect disparate things, whether it's an analog scan of a person's arm where they need a prosthetic attached, or as simple as a clip to keep your furniture together. So there's a lot of research-based explorations into sort of like self-contained manufacturing. This is a Dutch research project, or sorry, an Italian research project on ring spinning using bicycle parts and traditional ring knitting capabilities. So this is a sort of a high-low. It's traditionally ring knitting is like a factory-only manufacturing process, although it can be done by hand. And so this is sort of a DIY combination of the two that gives you scalability for that product. Does anyone have any questions? I feel like I'm out all by myself here.
Yeah, I'm just trying to moderate. I mean, anyone have specific questions, feel free to unmute.
Yeah. I like conversation, so if you guys are talking about anything specific in the 3D printing space too, I can address that. Or Wendy, do you have anything you'd like me to?
Yeah, I mean, I guess for us, a lot of the explorations between what we're actually going to do for the semester, and this is actually just week 2 of classes, is kind of looking into various ways of the smaller machines could actually print. Some of the students want to see if is 3D printing the best way to do something, or could they actually scale it up to do it in CNC as a formwork. So most of them are actually very familiar with most of the machinings in the fabrication lab. So CNC and 3D printing isn't a new technology, but for us, it's kind of understanding: is it possible to kind of use various different materials? Is it the most innovative way of producing on a small scale? What happens with 3D printing when we actually try to do mass production? these are some questions I think a lot of the students were bringing into the discussion, at least last week. From your experience with 3D scanning, how precise, I mean, as you said earlier, that 3D scanning doesn't give you, the technology, at least the open source technology, isn't giving you as precise scanning as possible. However, do you feel like the DIY machines offer a way to explore it beyond what we generally see on, like, kind of, you know, if we don't use our DIY machines, could we actually have a higher resolution with maybe Shapeways machines or, you know, object printers or 3D systems and so on?
Sure. Well, you know, resolution of a scan versus resolution of a print can be, in post-processing during the file, can be separated almost entirely. But I think the important thing to know about any DIY scanning capabilities is that you're probably going to be using either photogrammetry or something, or like the Kinect, and you'll be using visual triangulation. In the Kinect's case, it's using an infrared camera as well as a regular digital video camera, and so the software is really just taking all those frames and cutting out the outlines of the consistent objects throughout the frame and then sort of pasting them together. So it's a time-based process for the Kinect, which means that you could have changes in the form throughout time, especially if it's a living thing, as we experience at the museum a lot. If someone didn't hold perfectly still, they could end up with several arms coming out of their body, things like that, or just disfiguration in general. So for precision fitting, for things like prosthetics, you just have to kind of remove all variables in every axis possible. So whether it's fixing the camera, the Kinect itself, and rotating around the object, or fixing the object. So let's say I'm scanning my hand and keeping that perfectly still. You want to eliminate as many of the variables for distortion as possible. With photogrammetry, you're getting a more instant scan, but the data load is huge. So you typically need a lot of post-processing. If you check out Doob 3D, this is I'll put it in the chat. Yeah.
Another question.
Yeah,
when you have any hurdles when you're connecting the system, are there any kind of like fast track, by the way, don't do this, that you would suggest to us if we're moving forward with the Kinect system? And versus, are there any specific smaller systems that you've experienced that you really like and are, you know, student budget friendly?
Yeah. So the same guys that make Scanect, which makes the Kinect software pretty seamless between either a PC or a Mac, they also have their own hardware called the structure sensor. It was a Kickstarter, Kickstarter last year. So it's an adapter that can be attached to iPhone 5S and above, iPad, Retina Mini, and iPad, and so as long as you have one of those devices, and then the structure sensor itself, I paid the Kickstarter price, so I think it's a little cheaper. I believe it's around $400, but it's a really self-contained scanning hardware that can do up to like a full-size room, the whole room. Not unlike the Kinect, but the advantage with the Scanect bracket and the iPad usage is that you're not tethered to a USB cable. So the Kinect, when you have powered USB cables, they can't be longer than 10 feet because they need a power booster to make it even further. So you're pretty much limited to the 10-foot USB cable that the Kinect has. So I think if you're looking to scan challenging objects, then that doesn't allow for like easy navigation around the object. I think the structure sensor is really good to look at. It's an incredible tool. They've been updating the software regularly since they released it, so it's all of the color matching and fidelity is improving every time they release something new. The other thing to remember with photogrammetry and with triangulation is that it's still a reflected light medium, so you can never have too much light, especially if you want to capture accurate color data. So, just as a photograph can be underexposed, so can a scan. And the infrared camera in the Kinect and the structure sensor is meant to fix some of that, but you're still not going to get true color fidelity unless you're just basically shooting with studio camera lighting. And with video, that you need even more light than with a still camera. So just tons and tons of light if you're trying to get accurate texture and color data as well as surface data. Then I just can't recommend having a kit of lights enough. Just yeah, and so that's the drawback too, is that rarely does anyone have an ideal lighting situation, especially if you're trying to capture something sort of ephemeral. So it's not quite to the point of being like an Instagram type of situation where you can scan something and then it's like ready to go. But it's still very early on in the technology, so I think we're going to see a lot of advancement in that as well. The other scanning technology that you guys probably won't have, but you might have access to depending on the area that you're in, is the magnetic handheld scanners and the 7-axis ARM scanners. So those are they use a magnetic field, and you can't open your eyes. They use a laser sight to detect surface and topology. So you have to kind of be really careful with those when you're scanning people. But they're incredibly accurate. But again, a lot of data. It's a lot of data points. So you frequently need a pretty hefty processor to get it down to a manageable file size to be printed or even just checked for proper water tightness.
I think Bob Shield at UCL at the Bartlett, he did a kind of forest mapping project with the one that you spoke of. And then what he also did beyond that was a very interesting project on 3D scanning using active actors, like from a play, and from there working backwards on mapping kind of more ephemeral system. So it's kind of more of a poetic play. And that was pretty interesting. I could try to see if he has anything online about that, because he's been kind of tight on his research and hasn't really revealed much on it. But the presentation I remember seeing that he gave this summer was quite interesting on how he's using 3D scanning technology beyond kind of the typical medical field and kind of reproduction on prosthetics, but kind of adding an additional kind of storyline and poetry behind it. Another kind of interesting aspect of 3D scanning, I think, is the recent article. So it's in the showcase. The showcase is on the article that it was on Magazine, the 3D scan statue copyright sabbatical. What are your kind of point of views and kind of discussion on? Do you think 3D printing on a whole, and this is probably a large part of my own personal research, and it's actually a question that's probably come quite often with you guys, is how do you actually regulate from Shapeways if someone were to scan an object which is copyrighted, and then Shapeways as a mediator, just as an output person, or prints out an object, but are there any concerns? Have there been concerns of it? And how do you address those issues? By the way, your Shapeway mini blocks arrived. The ones I've been negotiating for the exhibition at Harvard, it just came. I could show you later on.
I'm very fantastic. Happy. That's great. I'm glad to hear that. Yeah. Oh gosh, this is
a long question. Very, very heavy question.
No, I mean it's like my favorite question though, because so I've only tangentially heard about this debacle, but from what I understand, the problem. Okay, how do I start?
You can step back and attack it whatever way you want.
Yeah, well, I mean, I don't want to redouble efforts. My first suggestion, in addition to whatever incomplete answer I give you right now, is to read Cory Doctorow's Information Does Not Want to Be Free. I think that the experience of the record industry and the movie industry now with digitization and access to production tools is a really excellent, not necessarily a map, because you know, songs don't have to deal with product liability, but you know, what has happened to the way that they attempted to use established copyright rules in the record industry is an excellent lesson for manufacturers to look at, because the concept of copyright is really meant for creators. It's meant for print, and it's meant for implying that if you have access to the means of production, that you must then intend to sell these things, when in fact that's no longer the case. If everyone has access to means of production for just about every type of media now, and especially with 3D printing, sort of the last frontier for duplicating things is sort of being settled. And so my first comment with these types of stories is always that, like, we're using, just like we're using old software to make files that will work, we're also using old legal statutes and precedents to manage technology that sort of fits in both and neither category at the same time. So as far as Shapeways and copyright, if an object is in violation of copyright, we fall under the Digital Copyrights Management Act, or DMCA as we call it in the tech industry. So we are considered a user-generated content safe harbor, which means that we do have to take down objects or things that violate, but only once we've been issued a takedown notice by the owner of the copyright. So it's actually not anyone on any website who hosts user-generated content cannot be responsible for every single thing being uploaded. Sort of the user is agreeing that they own that content, and even when you get a copyright takedown, it's usually contested in court. It's not something that can be settled just with emails. So I haven't gotten a chance to read the. Can you give me just like a 2-sentence about the 3D scanner story, just because?
Oh yeah, it was. It's not a huge article. It's more of a concern of, I think Cooper Hewitt was really pushing for the technology to kind of showcasing, you know, what museums could do with the technology of 3D scanning, and then they're showcasing. It's kind of like when MoMA had their Design for Elastic Mind, like new technology kind of exhibition. Yeah. And then what happened was there was a gentleman that started scanning a lot of things, including this Augustus, I think it's Augusta College casting of Michelangelo's Moses on campus, and then so the local photographer decided to use the sculpture like as a subject, and then what ended up happening was it was considered out of line. There was no legal rights for the person to do that, and then I think there was reproduction of or using the scans somehow for reproduction. But I think the article itself was interesting, not because of the scan of the sculpture itself, but it actually brings out question on what happens of like when, I mean, this happens to photographers all the time for sculptors currently who are doing public art, for instance. Mm-hmm. In the U.S., it's less kind of protected than in the EU and most European law, and don't want to get too boring in the law side of it, but I think it's usually artworks are condemned on welfare theory in the EU and the UK. So the artist has more kind of ownership to the piece of art. But in the US, a lot of times people are able to take pictures, and you could probably see that also when you go to an art exhibition. You're allowed to take a picture of a piece as long as it's not commercialized. But I guess the question is, what happens with the 3D scan, which is beyond just a kind of a 2D duplication of an image, when it goes into the possibility of production. So it goes into history of like Walter Benjamin and all the kind of mass production, the question of those issues, and these are more theoretical, and it'll probably bring up these kind of questions on Thursday on our presentation. So class, get ready some discussion on Benjamin. I'll probably send you guys the reading on that for the weekend if you like. But I think the larger discussion of 3D scanning is like how the public doesn't understand what is the right to steal, what is public domain, and what is considered a piece of art. And a lot of times the 3D scanning, if it were to be used as educational purpose, which is a lot of times I think, you know, what you're doing with scanning is to kind of further the art, further the field, further the science. Do you feel like lawyers are kind of overzealous in terms of trying too much to say, oh, this is copyright infringement, or is this actually, are there other ways to get around this, which is actually my larger question, because I think technology is so fascinating, and there's kind of the dance between the law and the tech is still kind of sensitive. So that's the reason why I was actually kind of curious on whether or not you yourself have experienced this, or since you're very kind of frivolent on.
Well, I haven't experienced it on like a high level like this with like a legal action in an article, but I do know that, for example, a guest artist at the museum used scan data from another artist in a jewelry piece, and they ended up arguing about it. And you know, both of them had, under the current copyright discussion, both of them had legitimate cases for why what they did was okay or not okay. You know, if you use an image, say in a collage, and you modify it, that's considered art, and it's not copyright violation. So if you modify something, I think it even has a certain percentage when it comes to things like software. 20% modification is considered, you know, not copyright infringement or even patent infringement in some cases. Back to the point is that, well, you know, with art, it's challenging too, because, you know, the experience of the art belongs to no one, but the images of the art tend to bring in museums money. But 3D scans, you can't really say that there's a market for that, but I can understand why they're concerned. It's interesting that this museum is stressed out about it, whereas the Met has the Met Media Lab, and they've actually published a how to scan their sculptures booklet. It's actually on the Shapeways blog. It's a former student of mine who wrote the booklet. I can send you the link later. But yeah, so the Met Museum here in New York is actually encourages people to scan the art and make copies and investigate further. So there's a lot of different tacks to this, and I think it just depends on their perspective of the collection and maybe where the technology might be going. But yeah, I don't know that there's like a quick answer for how to.
I don't think there's.
But I would say,
into point of view is.
Yeah, I mean, that's why I would say really like check out that Cory Doctorow book, because he talks about how like these laws were meant for complex industries and corporations who have lawyers to navigate this type of thing. This was never meant, copyright and attendant trademark laws were never meant to be applied to individuals. They were created almost 80 years ago when Walter Benjamin was writing Art in the Age of Mechanical Reproduction. And in fact, I think as on a philosophical level, I think that scanning and 3D printing are actually going to restore the aura of objects rather than what's the word? Dilute, rather than dilute it, as Benjamin talked about with 2D reproductions of art. What's the point in going to see Starry Night if you can see an equally good exact replica of it, right in your own home or on your own screen in this case. But with scanning and with 3D objects, but scanning in particular, the implication being that at some point you had to be, in order to get that scan, you had to be in the presence of the original object, or at least the object that you scanned. So it kind of closes the circle, in my opinion, of copying things and brings the aura back to the object, because there's no other way to get that scan. Wendy, I couldn't have scanned you unless you physically came to the Museum of Arts and Design on a day, and we stood together in a room, and I scanned you, and now I have that file, and that sort of is an ephemeral record in and of itself. So I think that's, whether it's the same as 2D copying, I don't know. It's hard to say.
I think that was a really good kind of closing question for everyone else posing on Thursday's class. Thank you so much, Lauren,
Yeah,
for
no problem.
having this prolonged discussion. If there are any questions, would you be happy that we'll make a list of questions and emailing you? And these are great resources. Thank you so much.
Yeah, and yeah, guys, can you hear me over the New York?
Definitely. We can hear you.
We're on the same street as a fire department, so this happens like 4 times a day. So yes, please email me. My email is lauren@shapeways.com. I would love to talk to you guys if you have projects. I also I have to plug our student discount, and also we have a student grant. So if you guys have a project that will require either precision printing or printing with something like steel or precious metals, you can apply for our education grant, and the grant is in the form of printing credit, so you can get up to $1,000 in print credit towards your project. The application is open until April 1st, although I'm getting letters from other students saying I need it sooner, which I think they're right, so we might bump it up to March 1st, but just you can check that out at shapeways.com/education.
Yeah, we'll definitely contact you on that.
Yeah, and it can be group projects, it can be individual projects, whatever. Yeah.
Great. Thank you so much.
You're welcome. Good luck, guys.
Bye.
Bye.